Okay, so we're working in SPSS and I pulled up the egg data. And what we're going to do is the examples of the two sample means test. Now, the egg data, I don't actually remember whether this was like actual data or whether I just made it all up. Yes, the statistics professor can make data up for illustration purposes. But so it's data on brown versus white and organic versus non-organic. Right now at this level, we only are going to work with like color and organic individually, not like a combination kind of thing. We could actually do that um with like ANOVA or something, but we're not going to do that right now. So I recorded the price of a dozen eggs and the color and whether they were organic or not. So we are looking at a independent samples. That would be the brown versus white or the organic versus inorganic. When we do the brown versus white first. And so it's an independent samples t-test comparing the two groups, comparing the price of brown to comparing the price of white. And it was actually done on the slides, but I didn't show you how to do it in SPSS yet with the actual data. So we have here two independent populations, brown and white. They're like, you're either brown or you're white as far as eggs go. You're not like overlapping and like changing colors or anything like that. Sorry, my finger slipped and I like pulled this down too far. So the null hypothesis is that the brown is equal to the white. That's the claim. The data has been collected, and then the metrics are going to be computed by SPSS. So how do we actually run a independent samples test in SPSS? And the answer is under Analyze, Compare Means. Pretty much all of Module 1 is under Compare Means. And this is the independent samples t-test. Now, if you watch the old videos, this is actually like this menu thing has actually changed a bit, so it is slightly different. Not significantly so, but it doesn't look exactly the same. So compare means independent samples t-test, you select this. Now, I had actually already played with this, so mine is not clean, so I'm actually gonna like I probably should just restart it. Um it's sort of bothered like software will sort of like retain previous work. So compare means independent samples. It's doing it again. I can't like erase this. But anyways, I selected the price variable and like moved it over already. Um, I want to run for grouping variable color. So when we do two groups, we have to enter the grouping variable. And then the test variable is the price, which is our quantitative variable. We're comparing the means for the groups on. Okay. Now, something else you have to do, and I'm not quite sure why, even though there's only two groups, brown versus white, like SPSS wants you to like define them and like, so you have to hit this and you have to actually enter B and W. Okay. Otherwise, it doesn't know. I'm not really quite sure why you have to do that because there are only two groups, but you have to actually like click and like enter like the two different groups as they're coded and then hit continue. You don't need to play with anything else. 95% level. Now, we're always pretty much interpreting 95% level. If you change the level, it's not going to change like the p-value because the p-value is independent of like what level you're testing at because the test statistic and p-value, they're whatever they are regardless of whether you're looking at 99, 95, or 90 because they're based on your data. If you wanted, in this case, it will change the confidence interval output if you change 95 to 99. We're not going to, but that's what this would do. So for now, just leave that. So otherwise, just move the quantitative variable over and the grouping variable, and then hit OK. And let's see what we get. Now, here we go. There's a lot of stuff on here. The first part is just the basic group statistics. This you could get in your descriptive stats. Brown eggs, white eggs, $4 for the brown eggs, $2.64 for the white eggs. That is this stuff here. That's where I got all this from. So this is just our descriptive statistics up here. This output here at first is a little confusing because on the left, I can't scribble on this. I wish I could. Maybe I can pull this into a Word document. So I'm being like probably more ambitious than I should be. Um, No, this is not a good idea. This is too advanced for me. Um, but the gray stuff is just out SPSS output now. So you see price and it says equal variance assumed, equal variance not assumed. This is this Levine's test. This is this testing for um, whether or not the two variance, remember, is the squared standard deviation. Standard deviation is in the same measure as the data, so I like it's much more interpretable. This is the issue of the two S1 and S2, which you can think of them as the variance, which is the standard deviation squared. How equal are these? So it's testing how equal these are or unequal. It's only a problem if they're way off. Here you see the standard deviation of 1.32 and 1.18. Those are not way off. So what Levine's test is doing is it's testing if these are way off. So the first thing you do is you look at Levine's test. You don't really, in fact, I don't even remember exactly how Levine's test worked. At one point, I actually literally knew all this stuff. I went to grad school like specifically in stats and took like literally the entire program in stats. At one point I actually knew like all the exact ways these are calculated. But Levine's test has a p-value associated, which is 0.407. What that means is that there's no significant difference in these standard deviations, and you can use the equal variance assumed row. Now there's two rows here. They're actually running two tests, which is a little tricky to see. So they're running a test in the first row, assuming the variability is equal in the groups, and the second row is if they're not. You use the second row if the Levine's test is less than 0.05 and significant. Otherwise, you use the first row. Now, if the Levine's test isn't significant, basically the first and second row are going to have the same conclusion anyways. And you can see when you look down here and look at the p-values, well, they're actually slightly different, but generally you're going to have the same conclusion if Levine's test isn't significant. So the first row is what we're going to look at because we can assume equal variances because it doesn't fail Levine's test. This p-value is not less than 0.05. So the first row, the test statistic is 3.218. That you could calculate if your little heart desired. That you could go and stick all the numbers into this formula here. And literally, like, you have the table to do that. I think I did this once, but I'm not gonna, because this would just go on forever. So if you plugged all the numbers into here, you should get 3.218. Okay. Degrees of freedom, there's 40 samples in two groups, so that's why you get 38. You don't really super have to understand that these days. In the old days, when you had to look things up in tables, that mattered. And what do these mean? Now, the mean difference is 1.36. Where does that come from? That's just these guys. Okay. And the significance here, the one-sided really doesn't mean much of anything in these tests, but the two-sided, this is the group 1 minus group 2 equals 0 or not equal 0. So it's two-sided in the sense of testing not equal 0. The p-value is 0.003, which I think was actually wrong when I brought up the hypothetical discussion of 0.02 before. That was not coming from this. But in this case, this is less than 0.05, so there's a significant difference. Okay, and that's the conclusion of the test. So, and you can kind of see that, but you can't just determine this based on the difference in means. Okay, so the p-value is 0.003, which is less than 0.05. That's also going to be less than 0.01, so we're good. The stuff I was discussing in the first part of the video, I think I might have gotten the wrong p-value, but hypothetically it's fine. Then we have over here this confidence interval business. You don't really need this. I mean, it's there, like SPSS kind of likes it. I think some people like to do like this confidence interval interpretation. It's redundant with the other results. Like, you're not going to get a different result from that. So that's actually what's doing this. This is actually the lower and high end. So this is a confidence interval for the difference of means. And you're like, why? Because it's looking at not the confidence interval for the mean of either group, but it's looking at the confidence interval for the difference of the means. Now, this does not contain 0. And because it does not contain 0, that's also redundant with a p-value of less than 0.05. Phew. So that is the excitement in interpreting this test. Again, the top part is just descriptive stats. The Levine's test, like if you see that these standard deviations are way off, the Levine's test will probably be significant. If that were the case, you would read the bottom row. but in this case, we just read the top row. The p-value associated for two-sided is 0.03. That's the important number there. That's less than 0.05, so there's a significant difference between the groups. Yay! That was brown versus white. Next, because there's more, I also tested organic versus non-organic because I have that data too. I think this actually was real data, but I think it's from probably 2021, 22, somewhere around there. It's not the current like $9 a dozen egg prices. No. Anyway, so this is the organic and non-organic data. Okay. So this again, this was actually wrong. I don't know where I got that from. That was the discussion part was fine, but the p-value was not actually 0.02, it was 0.00. I think my eyesight might have gotten that off. But anyways, because that also seems kind of high. But anyways, the discussion in that case was fine. But organic versus regular, this is just another example of a two-sample test because organic and regular, and yes, we're taking the same data and dividing it into two different groups in two different ways. That's fine. You can do that. So I'm going to compare the organic and regular. And in this case, again, the null hypothesis is that the organic and the regular are equal and the difference is 0. This is always the null hypothesis in a two-sample test, two-sample independent test. The alternative is that they're significantly different than from 0 in either way, and that they're two independent populations because organic and regular, you're either one or the other. They don't overlap. Okay. So this is the data that we're going to see in SPSS because this is actually basically the same thing, not quite though, because the permutation of organic white and non-white, this right here, 28 and 12. So they're different. These group numbers are different than brown versus white, which is irrelevant to this actually because it's just a different classification. So you see the mean price of the organic is like $5.10 and the inorganic is like $2.80. So it seems pretty clear that there's going to be a significant difference, but again, that doesn't determine that. The standard deviations, again, are pretty close. Like, I wouldn't worry too much about these being off. Levine's test will tell us if they are. Sometimes it's surprising. Like, sometimes it's a function of, like, sample size or something, and you will have a case where, like, they don't look off, but they are. So anyways, this time I get a test stat of negative 6.126 and basically a p-value of 0 and highly significant. How did I get that? I went in SPSS and I ran analyze, compare means, and I ran the independent samples t-test, and price is there. Now, don't rerun the group, the color. You want to go over here and you want to do the organic. So it's a different group. You want to define the groups. I don't know why you have to do this, but you do. And make sure that you change this to Y and N. There's only 2 groups, so I don't know why it can't pick that up. And then continue. So just make sure that that's done. If you don't define that, it's going to like choke and not run it. And then hit OK. And then you're like, oh my God, look at all this stuff. So the top part again, this is just descriptive stats. This is the old one from the colors. Okay, so we don't need that anymore. But so this is the organic and non-organic. The organic is $5.10. I think I flipped which one was first and second, but and so there looks like a difference. Now, and then we go down here, the Levine's test. The Levine's test just coincidentally is basically the same as last time, so it's not significant. The T statistic is 6.564. I think I had originally told people to just by default use the equal variance not assumed. I'm not really telling people that anymore because Levine's test isn't really that hard to interpret. When I first taught this class, it was just basically if you're not sure, you can always use the not assumed because this one is always not going to be as like stringent. Essentially this one you're not going to like get you should be okay with this one no matter what. This one you want to make sure you have equal variances. The T statistic is 6.564, which is like really huge. The p-value is astronomically less than 0.05, so they just do less than 0.001. The confidence interval does not contain 0, so all indicators are that there's like a huge difference between organic and non-organic eggs. So hey, that is the examples I have of the independent two sample t-test. Okay. So that's that. Then I have one more from the textbook, which let's do this one because we're in the process of doing this. Now this one, I have to make it bigger because I can't see anything. Here we go. So this one, I don't know how good I'm going to be at going back and forth between SPSS, but I want to enter one of these because I want to show you guys how to enter stuff too. So I'm actually closing out SPSS. Again, my heartfelt advice is do not do right overs of your SPSS. Like make sure that you just start it fresh and just do fresh data. There's reasons for that. Like you don't want to use column 1 for problem 1 and column 2 for a different data set. You just don't want to do that. It's just not a good thing. So the final two sample example I have, this came from some textbook, miniature golf scores, and then there's two teams. And so the question is asking, I don't know anything about golf, so I honestly don't know what a par 54 course even is. A large group of friends went miniature golfing together at a par 54 course and decided to play on two teams. A random sample of scores from each of the two teams is shown. At alpha equals 0.05 is the difference in mean scores between the two teams. So we have team 1 and team 2. Again, I mean, this is textbook, small data. Like realistically, I wouldn't like to analyze data that's this small, but let's do it because I want to also show you how to enter your data because you're going to have to enter data because, you got to do some work. So as SPSS extremely slowly opens because it's kind of mad at me, I guess, for closing stuff. But anyways, so here we go. This is a nice fresh blank slate. I'm going to try to read this with my old lady eyes. I don't know how good that's going to be. So we're going to have a variable that we're going to call team. I'm actually going to, so we're going to do team and then score, whatever these are. Okay. Now team should be it should be a nominal variable, and then score should be a scale variable. So this is what I'm setting up in the variable view. I mean, so I'm setting this, I'm just setting the variable types. This is the variable view, and then I go in data view. These are set up for me, and then I can enter my data. Now for team, I'm not going to actually do 1, 1, and 2. I'm going to do T1. Okay. It doesn't like that. I don't know why. Let me do T1. Oh, you know why? I do know why. Because I did type numeric. You need to change this to string. There we go. Now it should be happy. Okay. So we're going to do team, and then we're going to do T1, T1. I don't know how many of these are. I can't count. 1, 2, 3, 4, 5, 6, 7, 8. Okay, good. So there's 8 of these. And then there's 7 of the others. I want to do T1 and T2, not just 1 and 2, because I don't want them to look like numeric data. I think that's good. And then, so I'm going to actually read these. 61. Oops. I don't want to do that. Okay. 61, 44, 52, 47, 56, 63. Oops. It's really easy to enter data incorrectly if you're on an exam or something like that. 62, 55, 56, 40, 42, 58, 48, 52, 51. I think I have a win. Okay. So my data has been entered. If you're a good doobie, you probably should save these. I don't always save them, to tell you the truth. So here we have our data. What we want to do is we want to do a test comparing team 1 and team 2 to determine whether or not there is a significant difference. And so we're going to go to analyze, compare means, independent samples t-test. I think this is going to work. Team is our group variable. Define groups, T1, T2. Hit continue. And then the score is that, and then I think it's going to run just fine and dandy. Let's hope. Okay. And we hit go, and yes, it runs fine and dandy. So we get all this, and you're like, oh my God. Now this, we don't need this effect size. That gets beyond us. So what we're looking at again is the 2 independent samples output from SPSS on this test. The first part is super handy to have. It's just giving you your descriptive stats for each group, which I mean, otherwise you'd have to go back and run these like under analyze descriptive stats. So it's nice to have these here for reference. So for team one, the mean is 55. For team two, the mean is 49. The standard deviations are extremely consistent, so we wouldn't expect like an issue to be there. Um, and so that's just the descriptive stat. Now there doesn't seem to be there's a difference. It's not huge. I mean, it's 55 and 50 plus the variability. These are kind of variable, and 7's pretty big. And then we have down here Levine's test. The p-value for that is 0.937. You can't get more consistent than that for the most part. The t statistic is 1.524. That doesn't smell or that's not 1.96 is the reference value on the standard normal. This is a t, and it's a t with low numbers, so it's not going to be it's going to be bigger than 1.96, but this doesn't look like a significant test. The p-value is 0.151, and the confidence interval, when you look carefully at this contains 0 because it's minus 2.2 to 13.1. So the conclusion here is that there is no significant difference between the groups, even though, like, yeah, there's like a mathematical difference, but in terms of statistical significance, for the most part, there's no difference, and there's no difference between the teams and their golf scores. Levine's test shows no difference in the variability. So we're reading the first line. The first line, the t statistic is 1.524. Again, that would be the value from that no, I didn't close the slide. So that would be the value if you were to do this and actually hand calculate it, which you could do, but you don't have to. And so 13 degrees of freedom comes from two groups, and then 15 minus 2. That's actually, again, that's the kind of thing you need if you're doing the t distribution by hand with a table, but those days were long ago. And the p-value is 0.151. That's not less than 0.05. The confidence interval contains 0, so there's no difference between the groups. Awesome. So that is the independent samples t-test, and that's the end of part 2 of our show. Okay, thanks.